Welcome to a Seeq demo video. In this video, I will show an example mineral processing plant dashboard and how to create some of these analytics using Seeq. For mining companies with mineral concentration operations looking to implement advanced analytics, an overview dashboard is often a great place to start. These dashboards offer near real-time insight into how the plant is operating, including distilling operations down to when the plant is making versus losing money, key KPIs, or progress towards a facility's sustainability goals. Here we can see some of the example graphics that I might want to include in my dashboard, like the overall mineral recovery for my facility, a view into how my plant is operating by processing area over the past day. Here I can see that the dewatering step might need some further investigation, as well as time spent in various operating modes by area, a per area, utility, and water consumption view, and several breakdown views for units that I might be interested in. Let's jump in to see how we can create some of these graphics. To step through this analysis, I will be using the journal feature. The journal is a text editor that allows me to supply context to my calculations and link to views using work steps. This is great for documenting a use case for future knowledge, sharing amongst teams, or offering suggestions for root cause investigation to frontline teams that may need to kick off that investigation. I'll start by clicking on my first work step, looking at the overall effectiveness for this facility. In this work step, I have brought my operating mode string signal to this display. I can also grab this signal from the Data tab by quickly searching for it. Here I'll navigate to the Data tab and type in my search criteria. Clicking on it will bring it to the display. If I have an asset hierarchy available to me, I could navigate down this asset hierarchy to bring this signal to my screen as well. The benefit of using an asset hierarchy, besides the fact that it is a more human-friendly way of organizing and accessing my data, is that I will have the ability to scale analytics from one asset using the signals shown here to all applicable assets that might have similar signals. I'll go ahead and show an example of this later in this video. Here I will start by splitting my time spent in operating modes for this asset into productive and non-productive times, based on the state of my operating mode signal. Productive times being when my asset is running or being maintained, non-productive times being all other times like trouble, idle, or down. Using the value search tool, I can search for my operating modes. Here I'll show how to create a value search for whenever this area was in a running state. I'll simply look at my mode string signal and look for whenever the value is matching my running state. I can see the results of this search as capsules up at the top of the screen. These capsules are events, periods, when my state was equal to a certain value. In this case, you can see the running condition in purple. These capsules can be used to calculate KPIs during just the periods that we're interested in. After creating similar conditions for all of my other operating modes, I can go to the table mode in Seeq to display each of these periods of time in the form of a table. Here you can see my daily time spent in each mode, shown as a percentage. This was done using the scorecard metric tool, which you can see on the left now. This type of view is a great candidate to be included into my KPI dashboard. It allows me to drive continuous improvement, ensuring that I am maximizing the percentage of time each day in a productive state. Next, I will look at mineral recovery. To do this, I grab several signals for my facility. Signals like the process feed, tailing, and concentrate flow rates, as well as an analyzer mineral percentage for each of these streams. To calculate recovery, I will first totalize the mass of the mineral found in each stream over the course of a day. To do this, I'll be using the formula tool. The formula tool is more of a general purpose tool that can be used to accomplish a variety of tasks. Among these are simple math operations. The formula tool is found at the bottom of the Tools tab. Here you can see an example of my formula. I've simply multiplied my flow rate by that percentage. To calculate the totalized value, I use the signal from condition tool to totalize my flow rate over the course of a day. After replicating this calculation for each of my other flow streams, I can calculate my mineral percent recovered. To do this, I'll use the formula tool. In the formula, I can divide my total daily concentrate flow by my total daily feed, and I'll use the set units operator here to give my new calculated signal a unit of percent. For displaying my mineral overview dashboard, rather than showing a line trend, I would instead prefer to show these calculations in the form of a table. Here you can see the last value of my total daily recovery. Let's go ahead and add a max, min, and average calculation to this as well. I'll reorder them just so that it makes a little more sense. And then this type of a view would be something that I might be interested in inserting into my dashboard. Next, I'll take a look at excess utility consumption for each of my processing areas. To do this, I'll look at my water and electricity consumption, starting at a given processing area, and I'll go ahead and contextualize these using the non-productive and productive time periods that I found earlier. What I'm going to do is find the total amount of water and electricity used during my non-productive periods. To do this, I'll need to use the formula tool. On top of performing math operators, the formula can also be used to do other calculations like this. Here you can see the formula tool where I'm using the within function to limit a given signal to just within a different period of time, specifically my non-productive periods. Next, using the scorecard metric, I've totalized the amount of utility consumption for each of my signals during those non-productive times over the course of my display here. It's often helpful to further this analysis by showing my excess utility consumption on a per kilogram of product produced basis. Here you can see a table of my excess utility consumption per unit of product produced over the course of each day. This allows me to look at continuous improvement and drive towards my sustainability goals. It's often helpful to show these in context relative to each of my other processing areas. To do this, I'll go ahead and grab one of the table items that I want to display across each of my processing areas. Then using the asset selection button up at the top of the screen, I can go ahead and scale this out to all applicable assets. Here I'll go ahead and click on that asset selection button and navigate down my asset tree to the asset above the assets that I want to display this table across. It can be helpful to show these results in a more visual fashion, specifically a chart instead of a table. Here is an example chart that I have already queued up, where I'm showing excess electricity use across each of my assets. Returning to my organizer dashboard, I can navigate down to where I would like to insert some of my new content, and simply insert that content here. After inserting all of the content that I'm interested in monitoring, I can operationalize this dashboard by turning it to be live or auto-updating and sharing it with the team members that might need access to help me drive towards continuous improvement. Hopefully this video was helpful in identifying ways that you can deploy a similar dashboard at your mineral processing plant. If you have questions, please reach out to your CSM or AE at Seeq. We'd be happy to help. Thank you for watching.